Hi, Mr. Arkett here. In this video, I'm going to review 17, 18, and maybe 19 and 20. We'll see how far we get, and then if I have to stop and do another video with those. So let's look at 17, 18. It says write z equals 11 times the cosine of 135 degrees plus I times the sine of 135 degrees in rectangular form. Okay, so we have to figure out the cosine of 135 and the sine of 135 for this one. Okay. So let's draw our axes. Okay. That's the real. That's the imaginary axis. And then 135 degrees is going to be 45 degrees past 90, right? 90 plus 45 is 135. So it's going to be an angle that's here. Let me undo that. I didn't mean to do that last one. Okay. And actually, let me undo that one. That one's not very good. All right. Let's try and do an actual 45 degree angle here. Right about there. Okay. All right. So the argument is this 135 degrees here, but we're going to figure out the cosine off of the reference angle here, which is the angle right off the horizontal axis, the closest angle. So, okay, so we'll draw a little right triangle here. And then we want to take a look at the side. Since this is 45 degrees and this is 45 degrees, both the sides are going to be the same. Now, technically, they would be 11 divided by the square root of 2, or 11 square roots of 2 over 2, because the modulus is 11. But really, if we just want to figure out the ratios, let's say this is 1 here. That's going to be 1. And this is on the negative part of the real axis, so we're going to make this a negative 1 here. But the magnitude is going to be 1. And then this hypotenuse would be square root of 2, if those were both 1. Okay, so we can figure out the cosine. So the cosine of 135 degrees is going to be the side adjacent, so that's negative 1, over the hypotenuse, which is the square root of 2. And we want to rationalize the denominator, so we're going to multiply by the square root of 2 over the square root of 2. So it's going to be negative square roots of 2 over 2 for my cosine. For my sine, of 135 degrees, it's going to be the opposite side, so 1 over the square root of 2. Again, we're going to rationalize the denominator, so we're going to multiply by the square root of 2 over the square root of 2. So we're going to just get a positive square root of 2 over 2. Okay, so putting it into polar form, remember we had z equals 11, the modulus, times the cosine of 135, which is a negative square root of 2 over 2. So we're substituting in the cosine value, plus I times the sine value, which is square root of 2 over 2. So this is going to work out to be negative 11 when we distribute it, right? Because we're going to multiply by both this and both that. So it's negative 11 square roots of 2 over 2 plus 11I square roots of 2 over 2. And this is our rectangular form right here. Okay, so that's number 17. All right, number 18. We're going to write z equals 6 times the cosine of pi 6 plus I times the sine of pi 6 in rectangular form. Okay. All right, so we know the modulus. We have to figure out the cosine of pi 6 and the sine of pi 6. So you could do a quick conversion, and I'll let you guys do that, but cosine of pi 6 is going to be the cosine of 30 degrees because pi 6 is 30 degrees. And let's draw a quick 30, 60, 90. Okay, so and that's a 30, 60, 90 right triangle. The side opposite 30 degrees, if that is 1, and the side opposite the 60 is square root of 3, and the side up, the hypotenuse is 2, right? And this is your right angle. And this is your 30-degree angle. Okay, and that would be your 60. So the cosine would be the adjacent side, so the square root of 3 over the hypotenuse 2. And the sine, it's pi 6, which is 30, is going to be the opposite side, so that side, 1 over the hypotenuse 2. Okay, so we plug these in. Z is going to equal the modulus, which was 6. Z equals 6 times the cosine of 30, which is, or cosine of pi 6, which is square root of 3 over 2, plus I times 1/2. So we distribute, and we're going to get Z equals, well, 6 divided by 2 is 3, so it's going to be 3 square roots of 3, and then again 6 divided by 2 plus 3I. And that is my solution. Okay. All right, number 19. If the absolute value of Z equals 5 and theta equals 30 degrees, write the complex number Z in rectangular form. Your answer should be exact. Okay, so this is another similar one. We have a little bit different modulus this time. 5, right? So modulus of Z equals 5. Theta equals 30 degrees. So we can say Z equals 5 times the cosine of 30. Put it in polar form first. We're trying to get rectangular form, but plus I times the sine of 30. Okay, so that's going to equal 5 cosine of 30 degrees, we figured it out from the last one, times the square root of 3 over 2, plus the sine, it's going to be I times 1/2. So when we distribute it, we're going to multiply this and then that. So we're going to get 5 square roots of 3 over 2 plus 5I square over 2. And that's our solution. Okay. All right, for the next one, you're going to need a calculator. So I'm going to get my calculator and end this video and upload it, and then I'll make the last problem in a separate video. All right.